Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session I am discussing High Weightage Test 11, that is based on statistics. Okay, so let's see what were the questions which most of the students could not do. So this is first question. It says the mean of numbers 1, 2, 3 up to 15 with respective frequencies 1, 2, 3 up to 15 is. Okay, so dear student, as we know, if some data is given with some frequency, the mean has to be equal to summation the each data into its frequency and divided by summation of frequency. Okay, so here what we are given, 1 occurring 1 times, so it will become 1 square, 1 into 1, then 2 occurring 2 times, so it will become 2 square, 3 occurring 3 times, so 3 square, and so on till 15 square, and divided by sum of all the frequencies, that is 1 plus 2 plus and so on up to 15. Now this question can be done for general value of n also. This is nothing here. Okay, so if this can be done for any general value of n. Suppose this was up to n square, so it would be n into n plus 1 into 2n plus 1 whole divided by 6 and divided by n into n plus 1 by 2. So here n plus 1 will cancel, 2 will cancel this 6 3 times. So we will be getting 2n plus 1 upon 3. Here n is 15, so it will be 15 into 2, 30 plus 1, 31 by 3. So up to decimal, up to 2 place of decimal, it will be 10.33. So that is how this question can be done. Okay, coming to the next question. Now this question says variance of frequency distribution given below is. Now I will like to give you this question with two methods. The first method is, and before that method I will like to tell you what is the formula of variance. So whenever we are looking for variance, that is sigma square, there are two results that you need to remember. Number one, it is sigma of xi minus x bar whole square divided by n. Sometimes some data is given with its frequency, let's say fi, then it will be multiplied with fi here. In place of n, you will be having sigma of, in place of n, you will be having sigma of fi. So that is one formula. But if you open it, okay, then we will be getting this as sigma of fi xi square upon sigma fi minus x bar square. Now dear student, this result has a separate significance, I will say. It says average of squares. If you look at this number, you will see all the data squared and multiplied with its frequency and then divided by sum of all the frequencies. So it is actually average of squares. This is average of squares, and this is nothing but square of average. So average of squares minus square of average is what your variance is. Now we can do this question in two methods. Okay, the first method is that you directly use one of these thing. I think we can use this thing directly. Okay, but for that I will need the x bar. So what is x bar here? I think as we know the formula, sigma xi fi upon summation of fi. Okay, in this case this into this, so 4, this into this 6, again 6 and then 4 divided by, I think 4 plus 3 plus 2 plus 1, so 10. So this will become equal to 2. So x bar we are getting as 2. Now you can do it in both ways, this way also and this way also. Let me do first this way, which I have given average of squares minus a square of average. So in this case your sigma square will be 1 upon 10, because sum of fi is 10, into sigma fi into xi square. So 4 into 1, so 4 here, plus 3 into 2 square, so 3 into 4, 12, plus 2 into 9, that is 18, plus 1 into 16, so 16. and minus square of average. So that will be 2 into 2, 4. So what are we getting here? 4 plus 12, 16, 16 plus 16, 32 plus 18, I think 50, 50 by 10, 5, 5 minus 4, 1. So answer of this question has to be 1 only. That is A. Okay. Now I would like to tell you the other method. What will be the other method? Please listen carefully. If we have found x bar is 2, already we have found the x bar being 2. Now we can subtract all the data by 2. Okay, the very first formula, sigma fi xi minus x bar. So every data we can subtract by 2. We can subtract by 2. So this 1 subtracted by 2, 2 subtracted by 2, 3 subtracted by 2 and 4 subtracted by 2. This will give you minus 1. Okay, and this will give you 0, this will give you 1 and this will give you 2. And then we can apply that formula. That formula, which formula I am talking about? This formula which we give in the beginning when we define the variance. This comes later when we open it. Dear students, there is one more very important result which I will like to tell you here, and that result is that property is that if you subtract each data by any number, be it mean, median, mode or any other number also, like some random number like 4, 5, 100,000, 10,000, any number, if you subtract from each data, variance doesn't change. So what I am saying, suppose you want to reduce your number by, let's say, some number 3. So 1 minus 3 will be minus 2, 2 minus 3 will be minus 1, 3 minus 3 will be 0 and 4 minus 1 will be 1. Now for the same data set, minus 2, 1, 0, 1 occurring 4 times, 3 times, 2 times and 1 times, or for this minus 1, 0, 1 or 2, or for the original given data, for everything you will be getting same variance. That is a very important property. Okay, so we call this property as, let me write it this here. Suppose your data is, let's say, xi and its variance is sigma square. Now if you change your xi by xi plus, let's say, a, then also your variance will remain same. But if you multiply all your data by, let's say, some k xi, then your variance will become sigma square into k square. So that is some property that you need to remember, and JEE Mains, they have asked questions based on that multiple times. Okay, so my second method. So what I am going to do, I am going to subtract it by 2, but by now you must have understood it is not mandatory that we subtract by 2. We could have subtracted by 3 also or any other number also, but the advantage would be that if you subtracted by x bar, that is equal to 2, then your new x bar will be equal to 0. So finding variance will be now easier. 1 upon 10 summation. Now this fi xi square, so this will be 4 into 1, so it will become 4. Let me write the bracket, not summation sign. So it will be 4 into 1, so 4, plus 3 into 0, so 0, plus 2 into 1 square, so 2, plus 1 into 2 square, so 4. Now you can see this is also coming out to be 1. Okay, I need not to subtract by 0 square because now new x bar is 0. So this way also we are getting answer to be 1. Okay, so these are two methods. Now coming to this question, it says x1, x2, x10 be 10 observations such that their summation is 50 and their sum of squares is 300 actually. The standard deviation. Now standard deviation means square of variance. So we will first find variance. So here variance, as I told you the formula, summation, as we know the formula, sigma xi square upon 10 average of squares, because there are 10 datas, minus square of average. Okay, so this will be equal to 300 upon 10, so 30, minus 50 upon 10, 5 square, so this will become equal to 5. And this is not standard deviation, this is variance. Now we are looking for standard deviation, then it should be under root of this thing, so answer will be B. And you can see they have very cleverly given A option also as a 5. So there are chances some of you might write A as the answer. So please be careful whether they are asking standard deviation or variation, you have to be careful. For this question, I think that is the method. Mean deviation about mean of the numbers. Dear students, I would like to tell you first the formula of mean deviation, and then I will give you one important result to remember. So number one, mean deviation, whenever you are finding of a data about any number, it will be summation of mod xi minus that number a divided by n. If every data xi is given with some frequency, let's say fi, then it will be multiplied with corresponding frequency, and in the denominator this n would be, we can write this n also, that's not a problem, but it will be actually summation fi. So this is how we find the mean deviation. Now this a can be, if you are looking for mean deviation about mean, so this can be mean. If sometimes they ask mean deviation about median, so it could be median also. It could be median also, and other number also. Okay, so here they are asking mean deviation about mean. So what we will be doing, we will be finding first the mean. I think mean is very easy to find. Sum of all data divided by 5. Numbers are very simple, so we get directly mean as 5. Okay, so every data like 3 will be subtracted by 5, so it will be minus 2, but mod will be there, then minus 1 mod plus 0, then mod of 1, then mod of 2, and this divided by, because my data is equal to 5, so 2 plus 1 3 plus 3 6 by 5, so 1.2 should be the answer of this question. Okay, I was about to tell you there is one very important property, and that is that if you are taking mean deviation about mean or median or any other number, it will be minimum. It will be minimum when it is taken about median. If you take your mean deviation about median, it is minimum when it is taken about median. Okay, so that is one very important thing. Let me tell you, in JEE Advanced this year, there was one question where they were asking mean deviation about mean and median. It was a matrix match, and two of the options could have been eliminated just by knowing that median, if you take mean deviation about median is minimum, so you can easily conclude that about mean or about median, which one will be lesser, which one will be bigger. So this will be one important thing, so please note it down. It can be useful in JEE Mains exam also. Now coming to this question, a student obtained the mean and standard deviation of 100 observations as 40 and 5.1 respectively. It was later discovered that he had wrongly copied an observation as 50, which should have been 40. The correct standard deviation is. Dear student, this is one very important type of question. There has been so many questions that one data was wrongly noted, or one data is changed by, let's say, 40 to 50, or one more data is added. So this kind of questions are asked frequently in JEE Mains. Okay, and now JEE Advanced also they are asking question on this topic. So how this question is done, please listen carefully. As we know the standard deviation, rather I will go with variance, and we know standard deviation is just the square root of variance. So I will write the variance, which is equal to summation of xi square upon n minus summation xi upon n whole square, which is average of squares minus square of averages. Okay, so how we will do this question? Now we are given initially the mean is, I think, 40 of 100 observation. So from that we can directly say summation of xi will be equal to, I think, 40 into 100, because sigma xi upon 100 is 40. So the sigma xi will be 40 into 100, so 4000. Okay, we are also given this as standard deviation. So square of this, that means 5.1 square will be equal to sigma xi square, okay, upon n, that is 100, minus x bar, which is 40, so 40 square. Now using this we can find sigma xi square also. Sigma xi square will be equal to 5.1 square plus 40 square, that is 1600, into 100. Okay, 551 square is, I think, 2601. 2601. When you multiply by 100, this point will go plus this will be 1600 and 2 more 0. So this is what my sigma xi square is. Now dear student, because we know 50 observation, the observation which was having value 50 was wrong, it should have been instead 40. So now we can find correct value of xi. We can find correct value of xi. I can call this as correct here, and for that we need to remove 50 from this and we have to add 40 into this. So we will be getting this to be 3990. Okay, and then we need to find sigma xi square also correct, and the correct value of this would be when you 2601 plus 1620 and 2 more 0, you subtract 2500, the square of 50, and you add 1600, that is square of 40, which is the correct data here. Okay, so this is what my correct sigma xi square would be. Okay, so this will be, I think 900 we have to subtract, 2500 and 1600, 900 we have to subtract. So this will become 900 if you subtract from this. So maybe what I can do, this will be 1701, so 161701. I think this is what the correct xi square is. Now you may be thinking there is so much calculation here. So if you are feeling that way, I will give you one alternate method, a shortcut method for this question also in my next slide. Okay, but let us complete this question with this method also. So what should be my correct standard deviation? Let me do it here. So my correct standard deviation would be, when you divide this by 100, so it will become 1617.01, because summation of xi square upon n, so divide by 100 will give you this thing, minus the square of averages. So average of average is here 39.9, so 39.9 square. Now do this calculation, you will be getting this as, I think, 25. Now if it is 25, your standard deviation comes out to be 5. A is the answer of this question. Now I was talking about alternate method. So let's see how alternate method can be applied to this question. So there is one very important property, that if every data is subtracted by some fixed number, okay, variance or standard deviation doesn't change. So what I am going to do, let's assume you are having all these data x1, x2 and so on x100. Okay, now one of the data, maybe some xi place, you can say this was 50. Okay, with this 50, the sum of entire data is 4000, because mean is 40, so this is 4000. Now what I am going to do, I will subtract the entire data by 40. I will subtract the entire data by 40, 40 and so on 40. Now if you do this, okay, this will also be, whatever wrong data was, this will also be subtracted by 40. So the entire data, if subtracted by 40, so new mean will become 0. The sum of entire data will now become 0. Okay, that's one thing. Now with this data, with this new data, let me use red color for that, new data, variance will still remain same, standard deviation will still remain same. So 5.1 square will be equal to summation of, okay, and the new data I am calling as y1, y2 and so on. So all the data which I am writing after subtracting 40, I am calling them as y1, y2 and so on y100. Okay, so this will be summation yi square upon 100 and minus, because sum now becomes 0, average becomes now 0, so this will be just 0 here. So this will give you summation of yi square is equal to, I think, 2601. Okay, so for that data which we have obtained after subtracting 40 from each of them, sum of their square will be 2601. Now dear students, please understand, now this was some disputed data for us. Okay, this is 10 as of now, but what we will do, we will replace this 50 by 40, because this 50 was wrong, which means that we will be, removing this 10 and we will be adding 0 here, because I have subtracted every data by 40, so the new inducted data will also be counted after subtracting 40 from it. So my old data, or you can say the wrong entry of the data, 50 minus 40, which was 10, in this new calculation will have to be now added with 0, okay, because now we are adding 40 to it. Okay, so now what will happen, dear students, in this case the new sigma yi square, if I write sigma yi square new, or you can say correct also, it will be 2601, from which 10 will be removed. So 10 means 10 square will be removed plus 0 will be added. So this will become 2501. Okay, now sigma yi, what will this be? I think sigma yi earlier was 0. We removed 10 from it, and for that we add 0 to it to make it correct or new, you can say. So we are getting this to be minus 10. We are getting this to be minus 10. Now we can find correct standard deviation or variance. So standard variance would be summation of this divided by 100. So 25.01 minus square of averages, that will come from minus 10 upon 100 whole square. So this becomes 25.01 minus 0.01. So this gives you 25. Okay, this is variance, not standard deviation. So standard deviation would be 5. I hope you understood what I have done here. Okay, so you can compare the calculation. In this method, definitely calculation is more. In this method, calculation is less, because we have reduced data by 40. So obviously calculation will be less, but because there is a property, so answer will not change. So please be careful while finding variance or standard deviation. Use this property as much as you can. Okay. Coming to this question, this says if standard deviation of 10 observations x1, x2, x10 is 4 standard deviation, and that of another set 10 observation y1, y2, y10 is 3. And we are also given that each data x1 minus x bar into y1 minus y bar and so on. This is defined as capital X1, X2 and so on. And x bar is mean of all xi's, and y bar is mean of all yi's, small yi's, and summation of all this capital Xi is 80. Then we have to find the standard deviation of observations x1 minus y1, x2 minus y2 and so on, x10 minus y10. So dear students, here what we can do, if you are looking for standard deviation of this thing, so what will be the standard deviation? Please understand, we can write it directly with the formula that each data, that is xi minus yi minus their average, which will be average of xi's minus average of yi whole square divided by 10. Okay, dear students, we have two formulas for sigma square or variance. One is summation xi minus x bar whole square whole divided by n, and also we have summation xi square upon n minus x bar square. Okay, so I am using this one here. Also in this formula or this formula, there is a property that if you subtract each data by any number, variance doesn't change. So you can even think of this formula where you can assume like your each data is subtracted by x bar. So new x bar will become 0, and instead of xi you will be having xi minus x bar. So this is what I have used it here. You can call this or you can call this after using that property. Okay, now if I open this, first let me write this way, xi minus x bar minus yi minus y bar whole square divided by 10. Okay, so this is what we are looking for, this data. Now dear students, if we open it, we will be getting summation xi minus x bar whole square plus summation yi minus y bar whole square. Okay, and then minus 2 times xi minus x bar into yi minus y bar. Okay, and this whole divided by 10. Now dear students, I think here we have all the informations whatever is needed. First of all, if I combine, if I club this data with divided by 10, okay, so first thing if I write, let me write it here. Yeah, so summation xi minus x bar square upon 10. This will be actually variance of my first 10 datas x1, x2, x3, x10, which is actually 16 because this is standard deviation 4. So this will be 16. Similarly, plus yi minus y bar square upon 10. This will be variance of second set data y1, y2 up to y10, that will be 9, and minus, you can take 2 common, summation, I think this data is nothing but given as xi here in the question, upon 10. So if you put all these values here, so first it will give you 16, then the second one will give you 9 minus 2 into this data is 80 upon 10, so it will be 8. So 16 gets cancelled, we get 9. But this is, dear student, once again it is sigma square, that is variance, not standard deviation. And what they are asking? They are asking standard deviation. So in this case answer should be B, 3. Okay. So that is about this question. So that is the method I will go with for this question. I think the other method will not be that easy, so go with this method, that's better method. Actually already they have given a new thing by subtracting two data sets whose number is 10 in both of them. So corresponding data they have subtracted, and they are asking a new variance when you subtract these two data. So this is what they were asking here, and I think this is a best method for this question. Now coming to this question, the mean and standard deviation marks obtained by 50 students of a class in 3 subjects, physics, maths, then chemistry, are given below. Which of the 3 subjects shows highest variability in marks? So dear student, there is a concept called coefficient of variation, which is defined as standard deviation upon x bar. Standard deviation in the numerator and x bar, that is mean in the denominator. Or if you want in percentage term, then it will be sigma upon x bar into 100. The same coefficient of variation, if you want in percentage term, it will be standard deviation upon x bar into 100. Now we are given all the data, you just need to find CV. So for first one, standard deviation is 12, so this will be 12 upon 42. For this it will be 15 upon 32, and this is 20 upon 40.9. Now you can see the maximum value of this is coming for chemistry. You can check, this value is very close to 50%. Now this CV denotes the variability. More value of CV, more variable your data is. Less value of CV, less variable, or you can say more consistent your data is. So in this case they are asking which subject is having highest variability. So chemistry will be the answer of this question. Very simple question. You just need to understand this concept of CV, and you have to understand how CV is associated with variability. So answer will be C of this question. So that is all for this session. Thank you so much. Bye bachcho, take care.